Welcome everyone to the discussion on the value of ambiguity, data, proxies, and the limits of the computable with Mireille Hildebrandt and Wendy Chun. I'm very happy and honored to have both of them here. My name is Felix Stalder and I will be moderating this event. Before introducing the speakers, let me give you a little bit of context. This is the first of 3 events which we are conducting as part of a larger research project called Latent Spaces Performing Ambiguous Data, located at the Zurich University of the Arts. There we explore the notion of ambiguity in relation to data and processes of datafication. Data and ambiguity might seem like 2 unrelated or even mutually exclusive concepts, but as I hope we will see, they are not. And more than that, it is our claim in this research project that the way we relate these 2 concepts does matter a lot to the more than human worlds that we are inhabiting. From a computer or data science point of view, ambiguity is associated with noise, uncertainty, variation, error, bias, and other forms of bad data. And there are a host of techniques used all along the data pipeline to get rid of it, to establish objective relations between entities. Objective in the sense that 2 is always greater than 1. We, on the other hand, working within the context of the arts, see ambiguity not as something that we need to get rid of, but as something positive, as something productive, as something that should and can be articulated in a way that it opens up a space for debate, for different approaches, experiences, epistemologies to be brought to the task of creating situated, negotiated relations that are open to contestation and future modification. The research projects we are conducting takes the form of 4 artistic field studies and 2 transversal approaches. The 2 field studies by Gordon Savicic and by the Mediengruppe Bitnik focus on the generation of raw data with unstable meaning. 2 field studies by Cornelia Solfrank and Shusha Niederberger start at the other end of the data pipeline with the experience of living and acting inside datafied worlds and the opaque and ambiguous other constituted by the algorithms that personalize and adapt these worlds for us. The transversal to these field studies are the approaches of data science by Alexandre Putek and of media studies, headed by myself, which intertwine technical and social perspectives. But why is it important to find a productive expression for ambiguity in data contexts? Well, to put it really bluntly, to assume that data relations are actually objective in the sense I just mentioned requires that at least one side of this relation is turned into an object itself. And from the point of view of the large media companies, it is us and the rest of the living world who are turned into objects. But I don't want to take much more time now because we have really 2 excellent speakers who can help us think through these issues as we talk about the value of ambiguity, data, proxies, and the limit of the computable. So let me introduce them just very briefly to give you a sense of where they are coming from. A full and adequate introduction that would do justice to their remarkable bodies of work would take up a good chunk of our time. So I won't do that. This is what the internet is for. First, we have Mireille Hildebrandt, who's a lawyer and philosopher who works at the intersection of law and computer science. She's a research professor at the Vrije Universiteit Brussel and at the University of Nijmegen in the Netherlands. She's also a principal investigator of the research project Counting as a Human Being in the Era of Computational Law. And that research targets two forms of computational law: machine learning on the one side and blockchain technology on the other side. And I think today we're going to talk more about the machine learning part of that interest. Second is Wendy Chun. She's a research chair at the New Media at Simon Fraser University in Vancouver. Since its launch 3 years ago, she leads the Digital Democracies Institute, which aims to integrate research in the humanities and data science in order to address questions of equality and social justice, to combat the proliferation of online echo chambers, abusive language, discriminatory algorithms, and dis and misinformation by fostering critical and creative user practices and alternative paradigms for connection. But both of them share, and what makes them such great contributors here, is that they combine technical and non-technical expertise, and therefore, never seeing technology as neutral, they are uniquely capable of analyzing how the two are folded into one another and how we might perhaps be able to unfold and refold them differently. The evening has a relatively simple structure. Mireille will speak first for about 25 minutes or so, and then Wendy will react to the talk with a response to which Mireille will have a chance to respond before we open up the discussion. You are invited to post questions and comments into YouTube chat at any time, also during the discussion and during the talks, and I will bring them into the discussion once we open it up. We plan to keep this relatively focused and but conversational, and will end at 8:30 the latest, hopefully before online talk fatigue sets in. If you want to use social media to comment on the event, please use the hashtag latent spaces in one word so we can easily find it. And now I'm very happy to hand over to Mireille Hildebrandt.
Thank you very much, Felix. This is a wonderful invitation. I'm going to share my slides, and I have to warn you, I am a lawyer and I have too much text on my slides. Sorry. So this is actually Zurich. I was here a couple of months ago, one of the very few times that I was somewhere in person in 2021. This is a wonderful part of Zurich, and you can see that hidden on the lower side of the screen are the hidden proxies in latent spaces that we may be speaking about. So what's next? Here you can see the cup of the conference that I was speaking at the last time in Zurich. That was the conference on the history and the philosophy of computing. And it was a very interesting conference because there were very analytical philosophers. On one hand, very more historically minded people, and then some STS and media studies, let's say, sometimes quite incompatible, which is very interesting. What I want to speak about today is about proxies and their relationship with incomputabilities, about ambiguity and intelligence, about ambiguity in law, and about the relationship between the proxy and what it stands for. And that is hopefully the real world. And I will try to say something about what I mean with that. Let's first put my 3 cards on the table. And you must have already read it in the abstract that I sent. I believe that things that matter are not computable. And I think that's the case from a computer science and a mathematics perspective. And it's not so interesting because many people agree with that, other people don't agree. And it is clearly undecidable in many ways. But after saying that things that matter are not computable, the next step is important. They can be made computable. And this can happen in different ways. And it's the difference that matters. So to make things computable, developers need proxies, because computing systems cannot deal with the ambiguity of the languages we live in. Saying that we live in languages may remind us of many continental philosophers. I think it's also very important to say that we live in a real world, that's a physical and an institutional world, where real things are at stake. We have real things to lose. We might actually die. And that is a major difference with computing systems at this moment. Decisions on disambiguation, so if you want to make things computable, you will have to disambiguate them and then choose proxies. These decisions, so they are basically design decisions, have far-reaching implications. For instance, also a design decision is how to develop your hypothesis space in the case of machine learning research design. In the hypothesis space, the hypotheses are mathematical functions. And when I read latent spaces, I immediately thought of the hypothesis spaces that are latent in the sense that most people, when you talk about a hypothesis space, will not understand the word space there and will think a hypothesis is like something people with big shoes earn more than people with small feet. That could be a hypothesis. But clearly in these kind of spaces, mathematical spaces, something entirely different is at stake. And that has all kinds of consequences. So decisions on disambiguation, the choice of proxies have far-reaching implications. And I think there's a politics in these design decisions that require our keen attention. And the word "our" is very interesting here, of course. As a lawyer, as somebody who's interested in constitutional law, fundamental rights, and the rule of law, which is very close to political theory, the word "our" here means a lot. So who has the power to decide these decisions? These decisions, insofar as they relate to proxies, these decisions on what proxies to choose have a framing power. So as soon as you choose proxies, you narrow the space, and that limitation of the space is going to influence everything that you build on it. And this is not something that is normally shared. And in that sense, that is all latent. I think at some point, we need to develop a kind of spaces where a debate can take place about these design decisions, and that debate should be agonistic. So not agnostic, of course, as somebody once represented my talk, but agonistic. And that is key to democracy, key to, for instance, constructive technology assessment. But I think now we're at a point where an agonistic debate is important for all these systems that are connected with or thrive on machine learning research design. Now, let's speak a little bit about training data and tasks as proxies. So it's obvious that data itself is always already a proxy. To speak about raw data is, of course, an oxymoron. There is a translation between the real world and data. And that means that data itself is always already a proxy for that real world. There is a kind of representation, or the data can be a trace of something, etc., etc. Now, in machine learning, the start is with a data set on which algorithms are trained. And this training data itself functions as a proxy. It very often functions as what is called a ground truth. And this is, of course, an assumption. So you're looking at the distribution of the data in your training data, and you're making all sorts of assumptions, either that you want the output of your learning algorithm to achieve a similar kind of distribution, or that you want to predict something. That means you assume that future data will have the same distribution as the historical data on which you train, because evidently you cannot train any algorithm on future data. And that sounds obvious, but it has far-reaching implications. If you do supervised learning, then you have to label. I always find it very funny that people say that they are automating things, and that means that we now only need to do interesting work because the automation takes away the boring tasks. But many types of machine learning at this moment are supervised, and that basically means that the boring tasks, and even much more boring tasks than we normally do, are outsourced to gig workers, and sometimes even to people who are in a refugee camp that are put in a separate tent where they have to sit down and label things. Now, labeling, of course, again requires proxies, often for complex, ambiguous institutional facts. And I'm going to give you an example to give you a sense of what I'm talking about. On top of data being proxies, the training set being a proxy, the labels being a proxy, any type of machine learning has a task, otherwise the machine cannot do anything. And that task, of course, again must be made computable by way of proxies. Now let's take a proxy. Let's take what I would call an institutional fact or an essentially contested concept like fairness. Because why am I choosing this? Because in the realm of law, but also of computer science, there are whole subdomains discussing this. And you could summarize the question, is fairness computable, with can biased systems be fixed? So we all know that there's a kind of an attempt to legitimize these systems by claiming that they can be technically fixed. I think most computer scientists are aware that it's not that simple, but I want to focus now on the fact that fairness is a concept that we all live with, and that in order to compute something, so it is not computable, that is my first statement, but of course it can be made computable. Anything can be made computable. Now, the first step is that we're probably going to see justice as fairness. And there's a wonderful book written a long time ago where the distinction was made between distributive and corrective justice. In the case of distributive or geometric justice, and let's think of something like punishment, the point is that everybody gets punished similarly for a similar offense. That, of course, doesn't tell you how much everybody should be punished for that type of offense. To understand that, we have to go to corrective or arithmetic justice. And that means that one is punished in proportion to the severity of the offense. And that means there may be a difference in punishment between murdering somebody or stealing underwear. And it seems obvious, but we can immediately think of the question, if there are 4 people who are stealing underwear and one has all the money in the world to buy all the underwear in the world, while another person did not have any money and needed that underwear for their mother, themselves, or their children, whether that does something with the severity of the offense, the second type of justice, or with the similarity of the offense. So these are all decisions that have to be made. It's not the case that there is out there some sort of Platonic heaven that decides this. This is a decision that must be made, but it's good to frame the different types of decisions that must be made. And obviously, distributive and corrective justice are related, they interact with each other. Now, let's take the famous example of the fairness of detain-release decisions, where a court has to make a decision whether to sentence somebody to detention due to a criminal offense, or to release them, to perhaps give another type of punishment, or to grant that person parole or not. Now, is taking into account the probability of recidivism fair? If you think in terms of justice in relation to the offense, which is something that took place in the past, then taking into account the probability of recidivism is a bit strange, because that's something that hasn't happened yet. So it doesn't sound like punishment, but like prevention, and it's something else. So actually, in terms of distributive or corrective justice, that wouldn't work. So then we have to go to another type of justice, and that requires a utilitarian calculus. So you say, okay, if that person is released, more people might be victims. So you're then looking at society, potential victims, and calculating or taking into account that sort of thing. Now, the calculus is based on proxies. So the idea, if you use a machine learning system to predict which people are going to recidivize, what is the probability that they will recidivize, the comparative probability, basically means, if you're going to decide to ground your decision on that, that they're going to punish an individual based on features they share with a group, or rather a category of persons. And I'm not even going to discuss whether that's fair or not, or what we think, or you think, or I think. I'm just trying to make the point that there are all kinds of decisions that have to be taken. None of them is neutral. And it's very important that these decisions are taken at the level of the legislature, so democratic representation, which constrains the decision space of the courts. But even then, the courts will have a discretion, and that raises all these questions, especially if they are then advised by these sort of systems. The next question is whether using recidivism probability scores to decide on detention is fair. So we all know the example, I assume, a United States example. If Black folk recidivate more often than white folk, this will increase their probability score, and it will mean that they are higher on the list of being detained. Now, to be able to calculate such a score in terms of machine learning, you're going to use the distribution in a data set as a proxy for relative comparative recidivism. And that raises, of course, all these questions about the data set as a proxy. If that data set is used as a proxy for recidivism, we can raise questions like, where did the data come from? It turns out that very often these data do not come from convicted people, but from arrest. And if we then know that Black people are more often arrested, then that there is a bias already there, that we can see that that data set as a proxy is problematic. Of course, police may profile Black people. That's another type of bias. And we can also say that if people are marginalized, then perhaps even the fact that they commit offenses is a symptom of underlying unfair distributions in society. I'm sure that nothing of what I'm saying is new to you, but it's very important that I'm trying to frame, at least I hope you find it interesting, to frame this in terms of sets of proxies. Let's move a little bit deeper into the idea of ambiguity and look at ambiguity as I think is the idea of this this event, not as a bug but as a feature. And it's interesting that computer science philosopher Brian Cantwell Smith basically says that ambiguity is key to intelligence. He says human level intelligence and judgment honed over millennia is of a different order. And he's talking about different compared to what computing systems at this moment are doing. So this kind of intelligent adjustment requires getting out of internal representations and being committed to the world as world. And he has roots in Husserl and Heidegger. So he's talking about the world as a Gegenstand, as something that is not us and that has a certain resistance. And then he uses this wonderful term, the world as world, in all its unutterable richness. And perhaps if one is an artist or if one is into the humanities, that is a way of thinking about the world. But I can assure you that in the context of computer science, it's not obvious to speak of the world as something that has an unutterable richness. In 2008, we published a book on profiling the European citizen, written by computer scientists, lawyers, and philosophers and social scientists. We framed things then in terms of profiling, knowledge discovery in database. It was then called very comparable to what we now call machine learning. And when I explained in one of the first chapters what is meant with profiling, and I said that to navigate the real world, so that's the physical and the institutional world, we need to select and develop the right proxies. This relates to work by Gibson on affordances, the fact that an agent that is navigating a space, that whatever that agent does is relational towards the environment and the other way around. I'm not using the term affordances here in the sense in which it is often used in design. That was Norman. I'm very interested in hidden affordances, so things that are framed at the back end of computing systems that most people cannot see, but that have an impact on, for instance, their choice architecture, the kind of choices that they can make. And we can think of Bateson, one of the founding fathers of cybernetics, when he talks about the difference that makes a difference. So there are very many differences that we confront, that we see, that come to us. And the point is to find that one different or those differences that make a difference to us or to others that are dear to us or to the world that we are sharing and creating. So this was about ambiguity. Let's look at another term that's very close to it, and that's vagueness. And I want to run you through a wonderful quote from anthropologist Clifford Geertz in his book on local knowledge. And he said in that book, there is a part about law. He said, law is local knowledge, and then not local in the sense as place, time, class, and variety of issue. So we're not talking about metrics or variables, but as he frames it, accent vernacular characterization of what happens in connection with vernacular imaginings of what can happen. So he describes a complex of characterization, so the sort of mapping that you do when you navigate a space. And here we're talking about a legal space, so the mutual legitimate expectations that people have of each other. But at the same time, this is about imaginings, about anticipating. And that anticipation is not the same as a prediction. It's not an extrapolation. It's about creating futures. Stories about events cast in imagery, about principles, legal principles that bind people, that stabilize the expectations that they have of each other, that make them reasonably safe and at the same time free. And he says, well, that's about legal sensibility. And then he says, this is doubtless more than a little vague, but as Wittgenstein, the patron saint of what is going on here, remarked, a veridical picture of an indistinct object is not, after all, a clear one, but an indistinct one. And I've always loved that phrase. If an object is indistinct and you develop a very precise, clear and distinct concept about it, then you are really not being precise. You are creating precision, but you're not being precise in relation to that object. And then he makes the joke, better to paint the sea like Turner than attempt to make it a constable cow. So we were talking about ambiguity and then about vagueness. I'm going back to ambiguity, to Sonia Cook's wonderful work about Simone de Beauvoir, where she says that de Beauvoir's work on the ethics of ambiguity should actually be read as a politics of ambiguity. And she says, within Anglophone philosophy, ambiguity is often regarded as a fault, as an indication of the failure to properly achieve clear and distinct ideas. De Beauvoir argues that irresolvable antinomies are constitutive of human existence and that these extend from the ontological to the ethical and the political. And I think this is key. And I'm a bit worried that you're all going to totally agree with me and that you're already yawning and saying, yes, we know about all that. We already knew that. I'm a lawyer and I'm working with computer scientists and I'm doing research into computational law. Let's talk here about natural legal language processing, for instance. And statements like this in that domain are not at all obvious. I think ambiguity is indeed seen as a problem that has to be fixed. I can see that some computer scientists or lawyers who are deeply into this have now become very clever and to say, well, you know, we just have to make sure that unintended ambiguity is overruled, is made impossible. But if we want ambiguity, then you know, we can leave it there, we can sort of define it. And I think that the point that Simone de Beauvoir and Sonia Cook make is a very different one, that there you have no control over that. It's something that has to be faced and to some extent negotiated. So maybe you get the point immediately, but we are in an era where systems are being built that may to some extent replace law as we know it and may begin to make all sorts of decisions that are very difficult to contest. And that's why it is very important to call these things out. Let's then for 1 second look at a famous legal philosopher, Herbert Hart, who wrote about open texture, going back to Weismann and Weismann going back to Wittgenstein, where Hart said we should not cherish, even as an ideal, the conception of a rule so detailed that the question whether it applied or not to a particular case was always settled in advance and never involves, when you really apply the rule to the facts, a fresh choice between open alternatives. And this is very interesting because Hart is an analytical philosopher. So he will speak to a lot of lawyers. And basically he's saying that the open texture of concepts of natural language are a feature, not a bug. And it's very interesting to see here that if you try to translate natural language into computer code, so maybe we're not talking about machine learning now, but about computational law in the sense of rules as code, which means that when you draft the law, you draft it in natural language and at the same time in computer code to be able to foresee all sorts of ambiguities, contradictions, and the consequences of them being there. But the problem with that software code is this attempt to settle in advance all problems that may come up. And the beauty of law as text in the sense of natural language is this adaptiveness to changing circumstances. So let's move a bit further into law and go to another philosopher that has written wonderful things about the antinomian character of the world, but also specifically the law. Radboud, Gustav Radboud, may be familiar to people in German-speaking jurisdictions. He was a legal philosopher, but also Minister of Justice of the Weimar Republic. A very, very exciting time, of course, in the second part of the 30s. So he said the law must strive for justice. And he's talking about distributive and corrective equality. We could take Dworkin, another legal philosopher, who said, in a democracy, under the rule of law, the task of the government is to treat each and every one that is subject to the rule of that government with equal concern and respect. So he didn't say that everybody has to treat everybody with equal concern and respect. That's impossible, clearly. But he said the government is there not for itself, it's there for us, and it has to respect and be concerned with everybody equally. The second goal is legal certainty, the positiveness of modern law. So you have certain rules that make life reasonably predictable, and you have something called legal effect. So if the civil servant, the civil register, declares a couple, husband and husband, wife and wife, he doesn't cause them to marry. But the moment he declares that they are married, that declaration has performative effect, Speech Act theory, and that is what law does. So the positivity of modern law, the legal certainty that it offers, is not only connected with enforcement, with the monopoly of violence, but also with the performative effect of speech acts in law. The third goal is the purposiveness, that is the instrumentality of law. So if we want to develop a welfare state where people who do not have an income are provided with social benefits, as it's called, then we have to develop laws that serve that goal. And in the realm of the political, these goals are set, they're agreed upon, and then they will be translated into law. So law is an instrument, but it's not an instrument like any other instrument. Other instruments might be more efficient, certainly in the short run, but the law has certain qualities in terms of justice and legal certainty that tie the government and the unilateral imposition of rules, that is legislation, to a certain space. So this is a matter of checks and balances. Now, the interesting thing is that Radboud saw that in practice, when decisions have to be made, these goals are not going to be compatible. Sometimes yes, but very often not. And the beauty of his work is that he explains in many different ways that this incompatibility, the fact that they are antinomian, doesn't mean that that we have a problem here that has to be resolved. This is the human condition, and this is what we have to work with. And after the Second World War, after the Nazi regime, he said, a law that does not strive for, aim for these three different goals, and notably justice, is no longer law, doesn't qualify as law. Now, especially in Anglo-American philosophy, in a more analytical side, there are many attempts to solve this problem, to say, okay, that's antinomian, that means we can't reason very well with it. So let's rank them and say legal certainty is more important. Radboud himself has very often said how important is legal certainty within the law. But that is exactly not what he would do or what he stood for. So if you rank justice on top, then you reduce law to a moral order. And then, of course, the question is, whose moral order? If you reduce it to legal certainty, then you end up in a formalist, closed system. If you reduce it to instrumentality, instrumentality, so to things like efficiency, you're only looking at the goal and how to get there as fast as possible, then you reduce law to administration. And the challenge is how to tie them together. So last part, what proxy of what real world, the framing power of these proxies. Whoops. Let's take an example. Let's look at what natural legal language processing, so not NLP, but an LLP, what it does to the law. So if people do an NLP, they take as training data a corpus of legal text, binding legal text like legislation, constitution, treaties, or case law, or all of that. And they will be tempted to consider those corpora as the ground truth, to say, the kind of decisions that are taken in the case law so far, they determine how the follow-up cases must be decided. Some people call that precedent in common law jurisdictions, but we can all understand that it's very important for people to plan their life, to be able to understand how legal effect is not only going to affect them, but also others, so that there is some kind of trust in society. That there is something in saying that if the courts have made a certain decision, that you should be able to infer the underlying rules and principles of that decision so that you will understand how the court will decide a next and similar case. And we all know that cases are both similar and not similar, depending on what you pick out. This is important. This is connected with legal certainty. However, what happens if you're going to say this is the ground truth is that you're going to sort of fix it. And you're going to lose out on the anticipation that's in the law, and anticipation, as we saw before, is not the same as prediction. So if you train an algorithm on such corpora, at this moment, this is done, and this is used, for instance, in legal search engines. You could do that to identify relevant case law. So you have a case that you have to decide, and you want to know what relevant case law is out there. You could ask the system, and if it is well trained, the idea is that it will tell you what is the relevant case law. Of course, the relevance here, in information retrieval, the term relevance is the vanishing point of the entire domain. What is relevant to you may not be relevant to me. What is relevant in one legal domain may not be relevant in another. Depending on changes in other parts of the jurisdiction of the law, things will change. So what Geert said a couple of slides ago, that law is about local knowledge, is extremely important. And this is something that I think computer scientists find very difficult to understand sometimes. You could use it to detect relevant statutory law to see whether that statutory law is updated, and you can use it to predict judgment. It is used for that. And
Mireille, we have to keep an eye on the time a little bit.
Yes, yes. This is the last slide,
Okay.
and this is the last question. I could go on for hours, but the question is, what could possibly go wrong here? And I want to leave that as a question. So I'm going to stop sharing and yeah.
Okay, thank you very much, Mireille. And I think in order to open up the discussion, I'll hand it over to Wendy directly.
Thank you, Mireille, for a very thought-provoking and expansive presentation. I just want to pick up on a few things that you have brought up and contemplate what that would look like and why they're so important for us to think through. So as you mentioned, what you're trying to bring up and what you think is so important is an agonistic debate on proxies. And what an agonistic debate on proxies would look like and enable. And drawing from this, I want to just revisit the example of recidivism and that you brought up, and unpack what that might look like within a situation like that. Now, of course, many people have pointed out that the problems with some of the programs, such as Compass, which you were referring to, is the fact that they use proxies for race. That's often the example that's brought up in the popular press, that this is the problem. They use these proxies that are proxies for race. Now, I want to trouble that because I think that what's so key as we think about this, and this has been certainly something that data scientists have also been looking at in terms of understanding Compass, that they've argued that actually the factors that matter most are the age, time of first arrest, as well as errors within the information, right? And so there's been a debate over, okay, what proxies really matter and how can we understand this? Now, what's key, if we think through this debate, is it a proxy for race, such as education, et cetera, or is it time at first arrest or data errors, is that both of them are arguably proxies for racism. If we think through the policing that happens within the United States, the over-policing of some areas and the under-policing of other areas, being in the database in the first place is necessary for there to be errors about you. And so I think that one thing that this agonistic debate on proxies does is move us away from saying, oh, this refers to X, but actually say, oh, does it really refer to X? Or does it, through an interrogation, actually bring out this weird conflation of race and racism, which often happens when people just presume that these are proxies for race? And the reason why I bring this up as well is that a Compass, as I'm sure you know, was introduced during the Obama administration to get rid of individual bias. And the idea there was that racism comes from individual bias. So if you get rid of individual judicial bias, somehow you'll get rid of racism. Clearly, racism is still there. And it moves us away through this agonistic struggle to try to think through the ways in which this program perhaps inadvertently reveals the ways in which racism is actually a structural problem. And so I wonder, and thinking through this, the ways in which this can make us read these discriminatory algorithms against the grain and precisely open up and think through what is happening. And I think that what's absolutely also key in this discussion is something that you mentioned, which is so key, is that fundamentally these programs predict the past, not the future. when they're validated against things, they're validated against the past, not the future. And often the past that's put in, the so-called ground truth, is itself a deep fake, right? And so you have this bizarre situation in which what is being repeated are these certain deep fake pasts as futures. And so the question is, because again, if you think through the necessity of proxies as well, at a certain level, almost anything will be a deep fake representation, right? Because proxies themselves, through this action, as you pointed out, to narrow, right, will obviously not represent the whole. It can't, right? But I think what's absolutely key as well to draw from this is that as much as these proxies narrow, they also expand, right? And here you can think through the Proxy Politics project, which Hito Sterl, Vera Tolman, and Boaz Levin have worked on, in terms of the choices, et cetera, that are opened by proxies. And I bring this up because I think that what's so key in thinking through these proxies as latent spaces, and I think the notion of a proxy as a latent space is so important. Because for one thing, if you just think reductively about proxies, which is something that we're pushing against, a proxy is often a historical pattern or a habit that's presumed to be consistent. Therefore, X can stand in for Y. It's a stand-in. A proxy was someone who stood in for another. It also has a very interesting ecclesiastic history in terms of money that was given to the church as opposed to housing the people coming to visit. But there's also this idea that the difference between a proxy and an agent, because an agent too stands in for something, is that a proxy doesn't take a cut. That whereas the agent takes the 10% or whatnot and has certain latitude, the proxy somehow is faithful. But even when we think through this faithfulness and desired faithfulness, what again is key is this notion of it also, as it narrows, opening and structuring a certain type of space. And here I'm thinking about things such as, so what I find really fascinating just about latent spaces and the whole language of latent and manifest, and the history of latent and manifest within things like factorization and sociology, is when Robert Merton comes up with the term latent and manifest functions, which of course is very influential, and this is what emerges. He says, you know, I'm taking this from Freud. I'm taking this from Francis Bacon as well. And of course, he's not being, he's not saying, therefore I'm Freudian. No one would think such a thing. But rather that at this heart, there's this really interesting merging between this argument of what is manifest versus what's important, which is this latent or inadvertent thing. But there's a linkage between these two spaces. And so what's important as well, that this latent space just doesn't end, right? But within, if you think through the sort of dream sequence, or what Freud called the umbilical cord of the dream, right? It takes you forever. There's a way, and even in narrowing, you can keep going along this chain over and over and over again. And so what I find very fascinating and so important is the ways in which, because as you pointed out, the sciences and humanities and the arts have very different approaches to what is unknown or ambiguous. For this, because both scientists and humanities people value ambiguity, but one views it as something that needs to be solved, and the other thing as something to be celebrated. But if you think it through that solving of ambiguity, what's so fascinating is what's imagined structurally in this unknown space in order to solve it. So if we think through latent matrix factorization, for example, Two important ways to think through this are called the Indian buffet problem and the Chinese restaurant problem, which I find fascinating for all sorts of reasons in terms of this is unknown. We're eating what the other eats. You know, let's imagine this, which is unknown as a way to structure it. But it's a way to say, look, we don't know how many latent factors there are, for instance, right? But we're going to imagine that there's some combination of them that's there in order for us to solve the problem, right? So thinking through the already presumed existence of certain factors, et cetera, gets us towards understanding the ways in which these spaces are structured. And what I want to end with here, because I think it's absolutely important, and this is implicit, I think, in the research program, is the sort of necessity of proxies as well. Because here I'm thinking through Michael Mann's hockey stick. So I don't know if you know the hockey stick, but it's one of the most famous diagrams of global climate change possible. And I realize this will probably make sense to people also from hockey-crazed countries in Northern Europe, as well as Canada and the United States, right? But the hockey stick goes like this, and there's a blade, and he showed that global mean temperature will raise like the stick, right? Now, what's interesting about this is that he was attacked for his use of proxies, where people on the, who were attacking him said, first of all, he used, as you're well aware, there's tree ring data that's plentiful, but that's only good for certain areas of the world. And there are things like ice cores, right, which are far less plentiful, et cetera, et cetera. So if you just average them, you'll have a lot of tree ring data and not a lot of others. So not only did he use certain proxies for data, he also used principal component analysis in order to weight them in certain ways. And he was attacked by people who normally accept all sorts of models, especially economic ones, as absolutely true, for using proxies. This was his sin. And I think that what we're trying to do is get away from the notion that simply using proxies condemns you, to using proxies opens up a conversation about the choices that are being made that can help us understand and create a better world as well as better models. So I'll leave it there to open up conversation, as well as Felix, your comments.
Is there anything, Mireille, you want to add immediately to that?
Well, that was a very rich response. I'm going to be a little bit the devil's advocate. Maybe that will stir up things and also bring in some comments, maybe adversarial to what I'm going to say now. When I talk about agonistic debate here, in a particular instance of the COMPASS program, I think many people totally misunderstand what that program does. When Julie Angwin did her investigation and said there was something wrong with the false positives and the false negatives, the response of Evox was that the error was the same for Black people and white people. And then Julie Angwin said, oh yeah, really? But alas, the error for Black people was negative for them, and the error for white people was positive for them. So white people were treated better with the same error as Black, blah, blah, blah. Then Equifax said, yes, of course, but that's the law of statistics. Now, of course, that's not a law of statistics, but there is something that we would have to sit down and think about. I mean, we can go back to racism and we can go back to slavery and say that everything should be different. I totally agree with that. But now we're here. Now there is a court that has to make a decision. If you intervene and tell the system, I want the false positives and the false negatives for white and Black people to be the same. That's very simple. You can tell the system and it will come with an outcome. That will have a cost. Then to the extent that this may, I have to go back. To the extent that Black people recidivate more often than white people. And there can be all kinds of reasons for that. I don't want to talk about that. I totally agree with that. If you give that intervention to the system, then it will come at a cost in terms of victims. And I find that this is a discussion nobody wants to have. And so agonistic discussions about these systems are going to be painful for all sides, because there is no free lunch on any side. So I'm being a devil's advocate, but I think it is important.
Oh, to be clear, I don't think there will be a free lunch. I think agonism, if you go back to Chantal Mouffe, et cetera, it's not, you're talking about, it's not simply disagreements. And agonism gets us to some of those structural issues, which are very difficult to decide and can't be decided simply in terms of false positives or false negatives. So I think that part of what I'm trying to say is that this gets you through these discussions of proxies and et cetera, gets you to those difficult conversations, which I would say is not simply only about costs to victims, et cetera, but about those larger issues that you raised. And another question that is often raised is, in terms of these systems, should they be used at all, right? And if we understand these systems as perhaps, as in global climate change systems, giving you the most probable future based on the past remaining the same, right? We don't use global climate change models as predictive models in the sense that, yes, we accept them and therefore we're doing X, Y, and Z, but we actually use their predictions as the grounds to change the future. So I think that the part of the ways in which this opens up precisely these agonistic debates is in terms of thinking through, rather than accepting their future, saying, is this prediction correct or incorrect? But rather, what grounds does it open up for understanding and for intervening so that the future does not simply repeat the past?
One thing that I was thinking about both during the talk and then during Wendy's response to it was the issue of the proxy as something that stands somewhere in between kind of the data and the model. It kind of confuses or blurs that distinction that the two can be separate. And when you then think about the fact that these models work, as Wendy just said, on probabilities. And in a lot of cases, particularly when the models are complex, these probabilities are drawn based on correlations. We have at least 3 layers of kind of uncertainty here, both in terms of the proxy and its relation to whatever it's supposed to stand in for, the probability in terms of the type of knowledge that it creates, and then the correlation that is extremely difficult to ascertain whether a statistical significance is actually significant or something that comes out of a system. And I wonder to what degree you can really turn these uncertainties into a debate, or whether that debate immediately gets itself drawn into these endless kind of recesses that Wendy mentioned. And I wonder then whether that agonistic debate is actually a debate, or whether this is something that we can build into these models themselves, right? That you don't have simply one set of models, but a whole range of models that work on the same situation and then produce a kind of a range of outcomes. And again, but what kind of knowledge are we talking about then? And what kind of politics can we think about related to that type of knowledge that is so, uncertain or provisional or based on a lot of kind of factors that are, rather soft, let's say, keep it state like this.
I think that it's extremely important that, and I'm talking from the position of lawyers that are confronted with their own thing, the law, being transformed by these systems and that having legal effect. I think it's very important that we really begin to understand what the computer scientists are doing on their own terms. So respect their methodology. Think Isabel Stenger's ecology of practices. And I, for instance, hear people speak about optimization, and they think optimization as some sort of social science meaning or a folk meaning of some sort of instrumentality. But optimization is a mathematical term, and to have any kind of agonistic debate about the research design of these systems and about the implications of these decisions, we must become sufficiently literate in the other vocabulary, for instance. So that's one point, that's what we are trying to do, and that's extremely interesting. Another point is, I think that's a crucial question, question 0. Should we have these kind of systems like Compass? And my answer would be no, because why? They are very expensive. They have to be maintained. This is proprietary software. We can't even see whether, whether they're getting things right. And judges have been doing this, making these sort of decisions for a long time. Yes, they're biased. These systems are also biased. But to put your finger on the bias of these systems is going to bring us into all sorts of mathematical discussions that are going to be an elite discussion. So I think these systems are going to be extremely costly, and the benefits are not interesting. What I do agree with Wendy is that at another level of analysis, like trying to expose what is a proxy of what, I think that's one of the most interesting questions here. So is race a proxy of being treated bad for the past 100 years? Is race a proxy for racism? Is age in combination with income a proxy for racism, etc., etc.? So if you look at insurance, for instance, the question whether you can sue your insurance company for direct discrimination or indirect discrimination is going to depend on the question of what is a proxy for what. So they can figure out and discriminate Black people, and they can show that it's not direct because they didn't use the feature. But of course, there are many proxies together, many variables together with our feature. So I think that at the policy level and at the research level, it might be very interesting to use these systems to have a very interesting conversation about biases that might otherwise be very difficult to detect, but that to use these systems to make individual decisions actually misunderstands what is statistics.
Absolutely, and one can also think here of the Amazon hiring system, which was disabled because it discriminated against women, rather than saying, okay, don't use it, clearly don't use it. But what were the factors? How can we understand it? Because it's too broad to say there is a gender bias in tech. It would be more interesting to use these to analyze and understand. But I think that as well, we have to ask ourselves, is it going to expose something that hasn't been already exposed? Or to what extent is this exactly an expensive task to reinforce certain knowledge that we already have, but to frame it differently? I think the other thing I would point out is sometimes the justifications for having this system is actually a way to opt out of agonistic struggles, right? So the idea is, no, we don't want to deal with racism. We don't want to deal with these fundamental things. So we'll just have compass and this will make these decisions work. So it's an interesting way in which these models are brought in as ways to precisely avoid these struggles. And yet what they might do if we think about them against the grain is actually lead us back to these agonistic struggles in really important ways. So precisely the struggle to, or the desire to reduce ambiguity actually produces this field of intervention. The other thing I would say, I completely agree with you. So optimization, gradient descent, loss functions, cost functions, these are all things that are absolutely important for us to understand, because sometimes it becomes, you know, when they say, well, it's a deep neural network, we don't know what it's doing, right? But we know what logistic regression does. We know a lot of these basic fluencies. And I think that having these discussions in which all sides learn from each other, but also we work together because we do different things, and have that respect for, we are working together because you do something I don't do. But we can talk together about opening something up. And in many cases, doing interdisciplinary work that centers around finding that proxy, the stand-in, which is actually ambivalent because it stands in for very different things according to the different disciplines, but enables this discussion to happen, is absolutely key. And I think that therefore, there's a way in which the very concept calls for this kind of interdisciplinary struggle.
Let me perhaps bring at that point in a question from the chat, and it's directed to Mireille, and I'll simply read it. It's the easiest. Thank you, Professor Hildebrandt, for an inspiring presentation. I am wondering whether computing is really that different from the law, or for that matter, human language more broadly in terms of ambiguity. Of course, the law or human language in a certain theoretical sense is surely more ambiguous than data or code. However, isn't any interpretation and any application of the law or of language, which in a sense is the only way through which these phenomena live practically, also necessarily based on certain proxies, for example, doctrinal criteria? Of course, these are different interpretations, but computational functions are equally unstable and can be changed. For example, by getting in new data, new labels, other proxies, other tasks, other optimization strategies, etc., etc. And the question ends, are we perhaps not that special after all?
Oh my God. How much time do I have? 1 minute. No, I think that's a question. And when you look at, for instance, critical data studies and critical code studies, you can see that they are opening up, let's say, spaces to let's say to re-ambiguate. Let's put it that way. But I do think that it is important always to see the continuity. So to say, okay, first we had orality, then we had manuscripts, handwritten manuscripts, then we had the printing press. They have totally different affordances. They're all about natural language. Then we have code, we have data. They are not about natural language. But still we can see a lot of continuities. I totally agree. But it's very dangerous then to suggest that that means it's not really new or different. So I'm very much in favor of teasing out where are the continuities, where are the discontinuities. I'm a big fan of Marianne Wolf's, don't remember the title of her book, but she did research into dyslexia and into the working of the brain, into the working of the reading brain. And what she shows is that both the morphology, so the materiality, the shape of the brain, and brain behavior changes when we learn to read. So learning to read is very hard work. Our brains are not wired for it at all. So you have to force children to rewire their brain to be able to read. Now, we did that. So I'm, for instance, convinced we can do the same thing for statistics. And then maybe we can play around with these systems and they suddenly, they make us see ambiguity and new spaces, etc., etc. I also have some concerns if we are going to do that, because computing requires formalization, requires disambiguation. It's about logic gates. Whether you do data-driven whatever, the bottom line is logic gates. And that does make a difference. And I'm not sure we're not going to lose things that are key to our humanity. Marianne Wolf often says in her book, we must think about and decide what we want to preserve. And I know that a lot of people say, oh, we should not preserve, that's old-fashioned, and you know, it's not really new. I disagree with that. I think the affordances of data and code are very different. I'm also very much convinced that 95% of the systems that are on the market are not at all based on proper machine learning research design. They are actually, I dare say, crap, but they do influence us, and that's terrible. And are we all going to teach our children from an early age to understand statistics in order to be able to maybe get rid of those bad systems again? I'm very concerned about it. I don't have an answer, but at least as far as the law is concerned, I think we should tease out where is the continuity, where is the discontinuity, and where does that threaten the rule of law, fundamental rights. I hope that is something like an answer.
Yeah, I think so. Otherwise, we'll get a second kind of follow-up question in the chat, and I'll bring it in. But I'm wondering about this kind of this agonistic debate again, because that would be a way of trying to get, you know, as I understand it, out of this, you know, drive towards these objective relations or these, you know, overly defined spaces that have unambiguous solutions then created. But where do you see that taking place, and what is needed beyond, I mean, obviously an understanding for these systems, but if we understand these systems too well, we might have internalized their logic, which is kind of the problem you mentioned. So is there a space for, you know, multiple, you know, epistemologies to come to interact at that point, or in that space, or is this really about trying to stop the imposition of one new dominant epistemology by pointing out kind of internal contradictions and limitations?
My perspective is that computer scientists themselves are aware of the fact that a proxy is a proxy, that an assumption is an assumption. So it's not their problem. What happens is that somebody wants to sell something, or somebody has to get funded, and then they have to say that they make certain claims about systems. Let's be very concrete again. So the European Court of Human Rights in Strasbourg has a backlog of 16,000 cases. Now, of course, we can put all our tax money in getting people to sort those cases and to prioritize them and what have you. But yeah, there are a good reason to put all our money in healthcare also. So it's not going to happen. So they are now considering, or they have decided to use AI. Now, there are two responses to that. Oh, fantastic, embracing, or we're against that. Let's never do that. Oh, that's terrible. Now, this is the end of law. Having a backlog of 16,000 cases, to me, is already the end of the rule of law. So I would be much more interested in saying, okay, show me. What are you doing? What system are you using? Is it open source? Are you co-developing? Like in Brazil, for instance, the judiciary is developing these systems within the judiciary with some help from outside. What happens if the court says, okay, if we're going to do it ourselves, it's going to be very bad because we can't basically pay people for that, or we can't find them because they don't find it exciting. And we all know there's a scarcity in these kind of computer scientists. So we're going to outsource it. And the best system is actually proprietary. So I'm not even interested in judging that, but I want to know about it. And I want to know who takes these decisions. I want to, maybe we have to look into competition law and into the law on tenders. For instance, one of the things I would want is that in these sort of situations, I want to know what non-disclosure agreements are, what NDAs are in the contract. What is in the NDA? I don't need to know the content, but what types of NDA? So there is a political economy here around these systems, which is an entirely different perspective. But my position is that the choice of proxies is often dictated by an incentive structure economically that we absolutely don't want. And we also don't want to talk about it. We want to talk about individual choice as if that is not framed by the choice architecture of the same systems. So I think we need to have a certain level of concreteness. We have to, so am I going to wash my clothes by hand because I am against automation? No, because then I would not be sitting here. I would be busy with the washing, right? But I have a washing machine in this apartment because it was there, but I never use it. So I'm not against automation, but I'm also not for it. It depends, and I want to know on what it depends, and I want to know who will suffer. Who will suffer? Do these people that are going to suffer the consequences, do they have a voice somewhere? And I think this is one of the most difficult questions, because if we're going to sit down with the whole of the Netherlands and have a discussion, it's not simple. It's not simple at all. But I would like to see a fundamental curiosity into how are things framed by these proxies. What is a proxy of what? Sorry, yeah, please.
No, here I think the work of Ruha Benjamin, Sophia Noble, and many others have gone along the very lines that you're pointing to, which is so key. But along those lines, but going back to what you said in terms of everything comes back to logic gates. What's so fascinating about logic gates is that their representations are themselves proxies. So my background is in hardware engineering. And if you think through electricity itself, I mean, the idea that we have these simple, 5 volts or 0 volts, it never is 5 volts or 0 volts. Within even the computational logic of themselves, if you push it far enough, you get to exactly this sort of abstraction and proxy. And I think that many people have been trying to think about the incomputable, and here I'm thinking about Luciano Parisi and others, precisely in terms of how the incomputable comes up within these all the time, but then has to be cut off so that things become computable. And so there's a really nice way that this whole question of proxies brings out the limitations of the very logic that we seem to rely on. But I agree that not only do computer scientists realize that they're using proxies, to blame computer scientists for the racist use of proxies is not to deal with this whole issue. Because sometimes there's an assumption that somehow if we didn't have these models, I as a person would make the right decision. And that to me is unclear. And here I think some of what Felix is pointing to in terms of alternative models, or are there different realities that could be modeled, right? And bringing out is this a way to perhaps open this up? I'm not sure, But I do think that one thing we're all pointing away from is this sort of, there's often this sort of a presumption that my judgment wouldn't do this. And what I think that training grounds, training data that is drawn from so much of us brings out, and there's tons of problems with training data, is that we need to engage with what we're producing and how we're correlated in order to understand exactly what is being drawn on as these decisions as well. So to think through the relationship between the general and the individual, rather than to somehow think that the singularity of the individual would always protect you from the taint of the general. And here is where I think proxies could open up different ways into it.
Maybe that's a good point to bring in another question and use that kind of as a closing round, because it adds or kind of fits very well here. And it's from Saprai, and I simply read it again. If I remember correctly, Wendy finished with a call that we should use these proxies deliberately to open up a conversation on them. Who is we? Artists and designers are often dealing with uncertainty and ambiguity by deliberately cutting away data or recontextualizing in order to shed light on specific issues. Could that we you mentioned be expanded to others, and if so, to whom and how?
Yeah, so we is always a dangerous pronoun. And whenever one uses we, I think one is making an argument. And so I would say that to think through this we is to make an argument that it has to be something larger than what is currently in place. And yes, there are many different groups and many different individuals looking at this. Yes, clearly artists, data scientists, humanists, etc. But there's a difference between you and we. And what you does, even when it's used as a plural, still assumes a singularity. You. And I think that the assertion that there should be a we is an assertion that it's not simply including others, but building towards something, even if it's based, and there will be misunderstanding.
Yeah, so the question, who is we, that's that's a fascinating question. There's a wonderful, I think, article by Jaap van Brakel, he's a philosopher, on the constitution of the we in political theory. So it's a construction, it's relational, but of course for me that's all totally obvious. So the question is, how is it constructed? How does it exclude who? If we want to use proxies to better understand how we are understanding ourselves, and that may sound very recursive, but that's also the assignment of the we in a polity, to decide in what world we want to live, what world we want to share, and that shared world is a construction, a co-construction. Yeah, I'm totally convinced that our world is now, the latent space of our world is mathematics. And in the 16th, 17th century, that was in the world of science. But as Dan McQuillan has wonderfully shown in his talk about machinic Neoplatonism, it's no longer in the mind of scientists. Our world is run on mathematics. And I think, and maybe the first question alluded to that, it is very important that we, I don't want to fall in the education trap, let's educate people, but that we that we wake up in young children their understanding of mathematics. Mathematics is fun. It's fun. Yeah, it's to learn to play around with it, to feel at home in it. And I'm not talking about counting or doing algebra, but understanding what happens if you talk about X, how that groups things together, how that makes the building of systems possible, the wonder about that. I'm sure that small children can get extremely excited about that. So I think it is very important that people, this may sound so strange for a lawyer to say, that people, we, the people, love mathematics and feel the wonder about it. Because of course there's a lot to wonder about, right? I'm not a Platonic person, but I do see that there is something in mathematics that I cannot control. It's not a social construction or something like that. That okay, everything is a social construction, but that's a platitude, that's a cliche. It's much more than that. There's resistance. So if people would begin to look at the mathematics that is our latent space, that determines us, like Freud's subconscious, I think that could change things. That could bring some of the empowerment back. But what I do not suggest is that a mathematics teacher, yeah, you need to do a job, so you become a mathematics teacher, and then you stand in front of 4-year-old children and you begin to teach them mathematics. That's not what I mean. That's the opposite. So maybe we have to reinvent our love for mathematics. This is really a strange way to end a conversation with a lawyer, I admit, but I'm totally convinced of this.
Mireille, Wendy, thank you so much. I think a strange way to end is a very good way to end the conversation, because it kind of already points to the next one and to the need to continue this. We will continue this next week at the same place and same time with a conversation about ambiguity, scoring, and modeling, which is about quantifying and dequantifying social interaction, with computer scientist and cultural scientist Martin Warnke and the artist Ben Grosser, who has been working for the last couple of years on ways of dequantifying social media. And in 2 weeks, on April 5th, we are going into a very different latent space, so to speak. We'll do a workshop in person in Berlin at the Silent Green Kulturquartier, together with Tactical Tech, on ambiguous tools. And what we will be looking at is at all the kind of computer solutions to the pandemic that were developed under pressure to address the pandemic, and try to think about what will happen to those tools, where they will be employed, you know, now that we seem to have all decided that the pandemic is over. Because while the initial purpose for these tools might have disappeared, in the same way that the initial impetus for cybernetics had disappeared with the end of the Second World War, the tools and the ideas live on, and they will find new ways of being used. They will find new problems, define new problems to be addressed. But at this moment, they are in a very ambiguous state where they seek out new problems to the already defined solutions. This we're going to do in 2 weeks, and you're very much invited to both of these events. In the chat there are all the URLs, so you can find the detailed information. And for me, that's all, and I'm just thanking very much to again to Wendy and to Mireille and to everyone who listened to us now or will listen to the archive in the future. So thank you very much and have a good evening, or in Vancouver, have a good afternoon.
Thank you.
Thank you, Felix. Thank you, Wendy.